Hi, today we are going to take the factoring by taking greatest common factor. But before we start, we have to remember prime numbers. Prime numbers are 2 and 3, 5, 7, 11, and so on. So to solve the first problem number 1, we have to factorize 27 and 18. Let's factorize 27 by using the prime numbers. So we should start with 2. 27 can't be divisible by 2, so then we will go to 3. 27 divided 3 equals 9, divided 3 again equals 3, and divided 3 equals 1. Then we have to stop. To write 27y squared using factorization, we have to leave space for 2 and start with 3 times 3 times 3 because 27 has 3. Then times y squared, which is y times y. Then go to 18. We have to factorize 18. 18 divided 2 equals 9. Divided 2 again can't be. Then we will go to 3 equal 3. Then divided 3 equals 1. Then we stop here. Then we rewrite 18y as 2 times 3 times 3. Then 2 times 3 times 3. And finally times y. Then we'll take the repeated numbers. 3 and 3, and then 3 and 3, and then y and y. We'll take each one once. Then GC equals 3 times 3 times y, which is 9y. To write the problem using factorization, we'll do it like the greatest common factor will be 9y. Then first term 27y squared divided 9y. 27 divided 9 will be 3, and then y squared divided y will be y, plus 18 divided 9 equals 2, and y divided y equals 1. So the final answer will be 9y times 3y plus 2. Let's go to second example. In second example, 15m plus 3n. So we have 15 and 3. It's easy to find the greatest common factor of 15 and 3, but if you need to make it like the first one, it will be 15 and then divided 3 because 2 cannot be. 15 divided 3 equals 5. Divided 3 can't be, so we'll go to 5. 5 divided 5 equals 1. So 15m will be equals 3 times 5 times m, and 3n, no need to make it. 3n equals 3 times n. So to find GCF, we have only 3, and GCF will be 3. Then we have 3 as a common factor. Then inside 15 divided 3 equals 5, and then m plus 3 divided 3, 3n divided 3 equals only n. And the final answer will be 3 times 5m plus n. Let's go to number 3, negative 4a to the power of 2b to the power of 2 minus 8ab to the power of 2 plus 2ab. Trinomial, we are looking for the greatest common factor for numbers. And no need to make it by factorization method. We know that 4 and 8 and 2. So the greatest common factor is 2 because all of them can be divisible by 2. So we will take 2 as greatest common factor. Then we have a squared, we have a only and a. So we'll take the smallest power, which is a. Then we have b to the power of 2 and b to the power of 2 and b. So we'll take only b. Now, how can we find the terms after taking the greatest common factor? We have negative 4 divided 2, which is negative 2. Take care. And a squared divided a will be only a to the power of 1. And then b squared over b will be also only b. Then minus 8 divided by 2 equals 4. And a divided a, it's 1, so we'll not write it. B squared divided b equals b. Then plus 2 divided 2 equals 1. So a divided a equals also 1. B divided b equals 1. So in this case, there is nothing here, so I have to write 1 because 2ab divided by 2ab equals 1. And we have finished. Let's go to example number 4. We have 7, 21, and nothing here. So there is no number or 1 would be 1. There is 1. So we are not going to take common factor between 7 and 21. We have to take common factor for all three terms. Then let's go to y. We have y power 2 and u power 2 and u and u. So we'll take only u as a common factor. And then t in the second term and t. So you take also t. Say so ut will be the common factor. Here the numbers will be we'll rewrite it as it is. So 7 will be 7 because we didn't take common factor. U squared divided u equals only u, and t squared divided t equals t. So plus 21 u divided u equals 1, and t squared divided t equals t. Then minus ut divided ut equals 1. Then we have finished this example. In this kind of problems, we have to take to factor by grouping because the polynomial is more than 3 terms, 1, 2, 3, 4. So we're going to use each two together. In this case, we have 4 and 8. Let's take from this binomial a common factor, which is we have 4 and we have r. So 4r as a common factor. Then we will be q because we took 4r plus 8r divided 4r is equals 2. And for the next two terms, we have 3q plus 6. It's clear that 3 is the common factor. Then 3q divided 3 equals only q. And then plus 6 divided 3 equals 2. But now we have another common factor. We have the same q plus 2 and the q plus 2. So in the next step, we'll take it as a common factor. Q plus 2. And then in this term, we have q plus 2 times 4r. So we took q plus 2, we'll leave 4r as it is. And then in the next q plus 2 is here, then we'll put 3. So the final answer is q plus 2 times 4r plus 3. In example number 6, let's apply the same method. 3nb plus 15b minus 4n minus 20. We can take from this 3 because 15 can be divided by 3, and also we can take p. So we will take 3p, then open brackets, 3p we will still n, we'll leave, and then plus 15 divided 3 equals 5, and b cancelled with b. So in this case, we can take here minus 4 because we have minus minus. We can take minus 4. Take care of this because if we take minus, we have to change the signs inside. So negative 4n, so we will have only n. And then this will be plus. Take care of this because this will be plus. 20 divided 4 equals 5. So we have n plus 5 and n plus 5. So let's take another factor which is right, n plus 5. Good. And then open the second. 3b will left here. 3b minus in the second one 4. Now let's go to the example number 7. We have 2mk minus 12m plus 42 minus 7k. From we have here 2 can be divisible to and 12 and m. So we will take 2m as a common factor. Then in this case we'll have k minus 12 divided 2 equals 6 plus 42 and 7. Take care, 42 and 7 both can be divisible by 7. So we'll take 7 only. And then here will be 42 divided 7 equals 6. And then negative 7a minus k, negative 7k divided 7 will be negative k. But in this case, we have k minus 6 and 6 minus k. We need to that k minus 6 is the same as negative 6 minus k because negative will go here will be negative 6 and this will be positive will be the same. So we can rewrite it as 2mk minus 6, but here we'll make it minus 7, not plus 7. Minus 7, and we can put it 6 minus k, negative 6 plus k, which is the same as k minus 6. They are the same. So we can rewrite as, we'll take k minus 6 as a common factor times, in this case, the first term will be 2m minus 7. Take care that k minus 6 is the same as negative 6 plus k. In example number 8, we have to take the common factor from the first two terms, which will have 3b minus 2p squared. Then I think will be b only. We still have 3 minus 2b squared divided b will be 2b only. And from the second, we will take 18 and 27. We can, yes, by 9. So minus 9. 18 divided 9. Take care. Positive 2, not negative, because we took negative outside. Then it's going to be 2, 2b. And then minus, because we took minus outside. Minus 27 divided 9 equals 3. But here, the same as the previous example, we have to get 3 minus 2b, and we know how to do it. B 3 minus 2b, and then here we will change the sign to b plus 9. So directly make it, we can change the sign. Negative 3 will be positive and the 2 will be negative, so we can rewrite it as 3 is minus 2b. Now we can take common factor, which is 3 minus 2b times, yes, b plus 9. This is how to take the greatest common factor, whether the polynomial is 2 or 3 terms or 4 terms. Thank you for watching and see you later.